All right, here we are. It's serverless office hours. I'm gonna make the same joke every time, but I still think it's funny. I am not Julian Wood. There it is. Julian Wood is running around today. He's got some other obligations, so he could not be here. So I am stepping in, but I will never fill his big shoes. But I am glad to be here. My name is Eric Johnson. I'm a developer advocate for serverless at AWS. And I have with me two of the probably foremost leading experts on all kinds of stuff. But let's say for today on observability and distributed applications. So that's what we're talking about today. Super excited. Let me start on my screen here. Rahul, hang on a sec. Popat. Did I get it right?
Oh, you're
Oh,
muted.
you're muted, buddy.
Yes, you're right. That's exactly how it
Okay,
is
I got it
pronounced.
right. Rahul, tell us where you're coming from and what you do at AWS.
Uh, Not a very short story. So I'm with AWS for over 6 years now, close
Okay.
to city. So I'm in Jersey City, very close to New York City, and super cold out there in Jersey. And currently, I do support other greenfield customers, but my passion has been always serverless. I've done a lot of time and coding and POCs and whatever you can think of in terms of Lambda API gateways and SSQS and things like that at
Right.
reInvent and beyond. So yeah, my passion stays here. I'm happy to join Joe, which will be talking about observability today. So yes.
Love it. Love it. Now, Joe Alioto.
Yeah, you got it.
Man,
Boom.
I am 2 for 2 today. I slaughter names all over the world. I mean, it's just horrible how bad I do it. So I'm glad I got it right. Joe, tell us who you are, what you do.
Yeah, my name's Joe Alioto. I am a specialist solutions architect here that focuses on observability now. I actually recently moved in a new team from like focusing on North America to the worldwide team. And I have a passion for serverless. So I've done a lot in the serverless space regarding like different workshops, and I love step functions. Love me some step functions. I know
What's
you love
up?
some step functions too.
I do love me some step functions. Yes, sir.
Yeah. So I'm just here to kind of talk about best practices for distributed systems running on AWS. And obviously, we'll talk a bit about serverless because this is serverless office hour. So we're going to focus on that, but it's really going to come to like distributed systems. A lot of the principles are similar. Maybe how you specifically implement that might be a bit different, but the principles of what you're doing are going to be very applicable.
Yeah, we're going to fuzz the lines a little bit, obviously. I think when you get into this conversation, we're going to talk about, obviously, distributed systems, talk about serverless, talk about event-driven architecture, because a lot of those go hand in hand. The way I've always described it is we didn't invent distributed systems, but we made them a lot easier with serverless. And a lot of the work we've done here at AWS to do the distributed systems and to do event-driven architecture and all that kind of stuff. So before we go any further, and we could do shows on each of these questions, but all right, you're on an elevator, you get on an elevator, and the person gets on next to you and said, okay, I see your shirt says distributed architecture. What does that mean? Okay. Now Rahul, I'm gonna have you take this one, and Joe, your question is going to be observability because I want to define these two things when we kind of get in. So Rahul, what's the elevator pitch? I'm going to time you on distributed architecture.
So distributed architecture, as we all use day in, day out, whether we know it or not, it's based out of different individual components. Typically in technical terms, we call it microservices. They all come together to serve a purpose. Just a simple example, if I can give you, if you order something from Amazon, you have multiple steps. It can be put something in the cart, make a payment, and submit. So it can be 2 or 3 multiple microservices, payment service versus add to cart service, recommendation service, etc. And when they come together, you eventually buy stuff. So these all different systems together, when they are clubbed together to serve one service as such, in this case, e-commerce, that is called a distributed application.
Nice. And I would, and I think the thing I would emphasize that you did, but I'm going to do it too because this is what I do as the host. But the thing is that that idea of these different systems may live different places. Because sometimes when we think, like a model, well, yeah, Eric, we do different systems in a monolithic app. That's not what we're talking about here. We're talking about these things living on, hey, maybe I'm running this on containers and I'm running this in Lambda and this is running in step functions. I almost said step bridge. I don't even know where that came from. Step functions. I'm going to make up words as we go here. But this idea of, and the important part of that is if A goes down, B keeps chucking along until A comes back up. That distributed often gives you a lot of power to degrade gracefully, to keep going when things break, things like that. However, and this is my segue because I'm a professional, however, building distributed systems is hard. I mean, I'd love to go, it's easy. And we have made it a lot easier with this, but it's hard. And one of the hard parts is when you're debugging, when you're troubleshooting. And so something that's really critical is this idea of observability. Now, Joe, elevator pitch. What is observability?
Oh, observability. So observability gives you a view into how your systems or applications are performing, right? It's not, observability isn't just like we think of the signals, metrics, traces, and logs, but it's really like how you can consume those things and have visibility into those that can tell you more of an impact on potentially not just the applications or the infrastructure, but the business as well.
I think that's huge what you just said, okay? Because I can't tell you how many times I've sat with customers. I'm like, well, what are you doing for observability? What do you do? Oh, we got logs. We got logs. We're logging like no other.
For days. We got all the logs.
Yeah,
I'm
like,
a lumberjack over here. I'm chopping them down.
Exactly. Yeah. And it's like, well, what do you do with those logs? Oh, we store them. 7 years, store them.
Yeah.
Okay. Well, what are you doing with them? And then they look at me like I'm the idiot. I'm like, we store them. It's like, okay, but are you getting the story out of your logs? And I think that's really critical. And you hit on that. Is it's not so much the saving of the information, but it's the interpreting the information to see what's happening. Because in my belief, I mean, systems are always being fine-tuned. You're always kind of going, you never want to go, it's good enough. We're good. Now, sometimes it's like, it's not worth that change. You have to balance, and that's a whole nother conversation. But we're always evaluating, is this at peak performance? And that's how we do this. And so you all did, I think, Joe, was it you two together that did a chalk talk on this at re:Invent?
No, so it was me. And one of our buddies, miss you, Jeff Gebhardt. Him and I did it together. We all know each other. We all know Jeff that's here and some of our other serverless buddies, of course. He was a principal technical account manager that was here for serverless.
Yep. Okay. So we're going to actually dive into this just a little bit. This is normally on serverless office hours. So if you've never been to serverless office hours, this is usually always code. But we wanted to have this conversation because so I really encourage you, and these really are, you have 2 experts and a host available to answer questions on this, because observability is so important. And one of the things that I would tell you, and I'll probably repeat this later because I'll forget I've said it now, but so many times, all kidding aside, observability is something we wish we would have had when we're in trouble, right?
Absolutely.
We hit the point and go, we have no idea how to find out what's going on. And so my challenge that I do with a lot of companies is observability on the list when you're starting and when you're building? And that's what I really encourage folks to do. And I know Joe and Rahul, you probably do the same thing, is it's so important to start with observability. There's those things that we always bolt on later, authentication, authorization. We should authorize and authenticate. Observability, those kinds of things.
Hey, imagine not knowing who's authenticating to your systems.
Yeah.
Right?
Yeah, exactly.
Also, one thing.
So, what's that?
Go ahead, Rahul.
One thing before we start observability thought process is, why do you want observability? Basically, define your key objectives, whether it is a service level objective or a business KPI or developer productivity. What are you getting out of it? What the key insights you want? And based on that, you define what kind of metrics and logs and other things which you want to trace. Just enabling everything and hoping that you will get some insights may not be the right start exactly.
Right.
Yeah,
Now, I
no,
think that's
absolutely.
important, and I'm gonna throw this out because like when I started at Amazon, we had so many acronyms. I don't know what this means. So, what are those things you just said, Rahul?
So what is the purpose of this application? What kind of insights you want? Sometimes it can be you just want to have a good customer experience. So for that, what do you
Right.
need? Maybe
Right.
measure the latency, but sometimes it
Right.
can be because it's very costly, running your application. So then what kind of key metrics you want to observe, whether it is
Yeah.
not just the latency but also how long it is running, and that kind of thing. Whether you can do the sampling of the logs. You don't want to have all the logs, which can be very expensive. So in production, maybe you don't want the debug logs, that kind of metrics. So that defining that key KPIs, what you want out of your observability needs, is very important before even we start enabling all these services.
I think it's important to add also, I agree wholeheartedly with you said, because I mean, there's table stakes, and I'm going to ask
Yeah.
you all in the moment, what are the table stakes? What are the things, hey, we should be doing regardless? But then there's also, what environment are we doing? You know, when I build, like if I'm running a local environment, I turn off, I'm working a lot with step functions and durable functions. So I'll turn off like retries and I'll turn on heavy logging and things like that, because I want to know right away when something goes bad, and I want to know why and where and when and how, what. So all that's cranked up. But in production, I may not have, obviously I'm going to turn my retry back on, and I may reduce some of the logging and just move to error logging and those kinds of things, but it have the ability to kick it on as needed, you know. And
Exactly.
so, now, Joe, am I gonna steal thunder on what we're gonna be showing in a minute if I ask you what are the table stakes in observability?
No, let's just jump to it. I think I should just show it, and I think we kind of know what these things are. So these are the fundamental observability data types, commonly called pillars, but they're really kind of like signals that we consume, right? So logs being, you know, those single entries, whether it's structured or unstructured logging. Maybe we'll talk about that more in a minute, which kind of tell you what happened when, right? The metrics that give you some details, they're usually numeric in value around some sort of thing. Like if you're thinking like of an API caller, like a web front end, if you're getting like what type of methods are running, how many post requests are running, how many 500 errors, 400 errors, 200 requests we're receiving or responses we're receiving, getting numbers on that. If you think of systems like the infrastructure itself, coming back down to that, what CPU utilization is, memory utilization, things like that, disk IO, like different metrics that we can start to assess how something's behaving, how it's performing, I should say. And then the traces. So traces are really important with what we're going to talk about today. They're not going to be everything we're talking about, but they are really important with distributed systems, because traces specifically let you track kind of end-to-end what's happening within your system or systems. If you have built it in a way to where you can see through the various services and see end-to-end transaction, not just from one, microservice perspective, but potentially end-to-end from where it starts all the way to the end, and be able to get some insights on what's happening, where the failures are specifically occurring, and then understand like where you need to focus your attention if things aren't working as expected.
So the way I look at this, and tell me if this is right, because I'm not, all kidding aside, I'm not the expert in observability. I'm pretty good at it. Don't get me wrong. From what I do, obviously I've had to fix a lot of things. I've also broken a lot of things.
Yeah.
But so kind of the way I approach it is one, and obviously if I'm logging, I'm a huge SAM fan. If you're not familiar with the serverless application model, I know you two are, but those of you watching, and there's a command called SAM logs that will actually aggregate the logs for all the resources in your application. It's one of the most underutilized and underknown. I mean, it's my favorite feature, right? So I will take that habit, just cranking out. I can run some filters, just show me errors, those kinds of things.
Yeah.
And then it'll show me what I need. And I debug with that. But when I'm looking for problems from end to end, traces are usually where I start.
Mhm.
Does that make sense to you?
It does,
Yeah.
absolutely.
Okay.
Absolutely.
Yeah, because and of course it's about, if I have an error, it can tell me, okay, it's a good chance it'll tell me that, hey, this is where that that error is, or this is where that latency is.
Yeah,
And
absolutely.
so those kinds of things are super helpful. What are some of the tools that you go for with traces?
Sure. So, I mean, there's a few different with AWS, talking about AWS specifically.
Yeah,
You know,
and bring in partners too. That's fine too, because
yeah.
there's some great
Yeah, oh,
partners on
absolutely.
this.
I'm happy to
Yeah.
name them. So, well, to get your traces, right, we have X-Ray, which is, it's been around for a long time. That's a great way to get traces that's
Yeah.
native to AWS. But another very common one, and it's becoming more and more common across the industry, is OpenTelemetry. OpenTelemetry is an open source project. It's like one of the top CNCF projects, right? For kind of having more of a common way of collecting like metrics, logs, traces. There are other things such as profiling and there's other things we won't dive into too deep here, but of a common way to kind of get that data and then being able to put it at a destination so that you can start to do the observations and understand how things connect together. When we come to partners, there are a lot of good partners that do that. Actually, before that, in AWS, to kind of view those things, you can actually go into CloudWatch and you can view your traces. There also is an application map if you've integrated with APM, our APM product, application signals, and you can kind of see how things tie together on services. There are lots of good big partners, from Datadog, New Relic, Honeycomb's fantastic as well when it comes to tracing, and they have great products. There's many different observability partners. Kind of.
And I'm going to call you on a buzzword here for a second.
Go ahead.
So you said something earlier, CNCF. What is that?
Yeah, that's the Cloud Native Computing Foundation. So that's where a bunch of open source projects let me name another one you might be familiar with, like Kubernetes. Have you ever heard of that? Is that a thing?
Can't spell it.
I don't think anyone knows what that is here. I don't think
like
anyone
a K
knows
and then there's an 8 in there. So
But if you do know what that is, that's a project that's
this
it's a
is
small
serverless office hours, Joe.
Yeah, I know. But you asked the question, so I had to give the answer. That's how it goes.
We're good. We'll wrestle later.
There's a bunch of different projects, open source projects. Lots of people contribute them, and it just helps the projects mature, evolve, grow. And there's very specific people that kind of own that, manage it, and make sure that it's maturing in the way that they like, right? So,
all right. So I'm going to pause you there for a second. There it is. Pause you there. So we have I don't have any questions coming in at the moment, but I am going to say real quick, man. Two things. If you're watching this, I would encourage you throw a question in the chat, and I will. I mean, we can play Stump the Chump too.
Yeah, it's fun.
I will bombard these gentlemen because they're a couple smart guys. But if you got something you're struggling with, throw it in here. And if you don't, tell us where you're watching from. We have quite a few people watching, so we'd love to see where you're watching from. And we already got some people giving us the hellos. Fabio Matias Mantelli, I think I said that right. I may have divided that the wrong place, but we love seeing people say hello and where you are, and we've got Erie Edits from LA and so forth. So yeah, throw in your questions if you've got them, and then I will come back. Now I have a question, really quick. We have some Vancouver, nice. So Rahul, this is for you on the distributed nature.
Yeah.
And tell me if I'm right or wrong, but tracing, I'm gonna index on tracing a little longer, really became a thing in distributed nature. True or false?
100%. Yeah, totally. Because when you think of distributed applications, it can be from tens to hundreds of microservices talking to each other. So when things go wrong, that's when you need this observability. And that point, it is very hard to figure out which 56th application failed out of those 100 applications, microservices. So that is when we need the tracing, which is basically a complete user journey from point A to point B, which tells you and where you can aggregate together to see the trace. When we say trace, it's basically the journey. And how do you tie them together? Typically, it's using some kind of correlation ID, which is one unique ID which is consistent across from A to B, and then you figure out where exactly it's failing. So totally, tracing is super important out of all those three pillars when it comes to distributed nature of the application.
So I wanna talk about that because in Joe, you're probably gonna get through like maybe an eighth of this deck because I want to talk. So, but I have lots of questions. So I don't want to talk, but I want to ask you. You said that's done by an ID. How do we do that? Now, some of that's built into the systems, but how do developers use this ID? And we don't have to go. You don't have to go into the nitty gritty of it. But I'm curious of if you've never used tracing and kind of use that to your advantage, how would a developer do that?
You want to talk? I can take it if you want.
Yeah,
to
no.
take
So
it.
I was reading the. I saw
I
a
can
great
do it.
comment from Nelson. That's why
Okay.
I was reading
I'm gonna
that.
throw that up in a minute too, but it's got Kubernetes in it, so I have to brace myself. So I'll get to it though. Yeah. So
So
go ahead, Ro, or you know,
very quickly. So there are a couple of ways to do it. At AWS, typical serverless architecture, if you think about it, let's say super simple 3-tier web application, API gateway, Lambda, DynamoDB. For API gateway and Lambda, we have made it so simple that with a checkbox, and if you're using SAM with one line of active tracing equal to true,
right.
you just enable X-ray. What it means is it starts collecting the correlation ID or the full trace from API gateway to the Lambda. And for the other services like DynamoDB, or let's say some other services which you're calling AWS services from your Lambda function, the typical way of doing it is you get the X-ray SDK in your code and wrap all your calls to the DynamoDB with that X-ray SDK. So that basically gives you the whole picture of what is the flow, and not just the flow, but how much time each segment is taking. What you can also do with the X-ray SDK, let's say if you have a bigger Lambda function, which is debatable, which you should have or not, but let's say in that Lambda function, if you're doing 3 things, and if you want to measure the time of each individual 3 things, you can also create subsegments within a segment of this X-ray. So that way you can also dive deeper into one application code itself. And this is all visually available once you do this in the nice CloudWatch X-ray console, where you can see how much time each individual component is taking. That is the best practice and the easier to get started with. Enable X-ray, that's the easy. Wrap it around all the downstream application code with the X-ray SDK, and then you get the complete end-to-end tracing.
I love that, and that's perfect. And so I really encourage folks. One of the first libraries you're going to add is the tracing or the SDK. Also, and I'm going to post a link here in a minute. Power Tools does a lot of that work for you as well.
Yes,
But the Power Tools
great.
tracer, yeah, I probably just stole your all's thunder on that because you're like, oh, we were going to say that, but yeah, Power Tools does a lot of this work for you, where it's going to do that tracing. All right, I've worked myself up to this, so I'm going to throw this up. So here's what Nelson said. He said, from Joe's comment on K80s, whatever that means. Tracing is super critical when you have K8s clusters. K8s is Kubernetes for all of you who don't know. A few pods per deployment, one specific pod having issues because, yeah, I absolutely agree. He goes on to say it's pretty much impossible to find those tiny short-lived outliers without tracing. And then I think he was just trying to make me feel better. Yes, it could be Lambda in managed instances as well. They're just too good to have issues. I agree with that. I think that's a well thought out, brilliant statement. Nelson, I appreciate the conversation.
Hey, could you
pop
Damien's question? Because I think this is important. I think it's
that's where I was going there, Joe.
I'm stealing your thunder now.
Who's hosting this?
No, so X-ray is not being deprecated for OpenTelemetry. That's not what's happening. The SDK, not the service, the SDK specifically is moving towards OpenTelemetry to support the more open framework. The industry as a whole is moving towards OpenTelemetry, right? It gives customers more flexibility of what they can do. Here's kind of why, though, if you think about this. This is like kind of taking a brief, not even really a history lesson, but a common problem before. With observability tooling or any tooling, in the past, it was always like, hey, we have to deploy these agents and install these binaries on our systems that we have to use to get our telemetry to whatever that vendor is, right? And it's their specific proprietary thing we have to run, right? So when it came to saying, hey, we have this long contract with this vendor, and we kind of want to see what else we can do. We think maybe it's getting expensive. Maybe we just want to see what else is out there. Maybe this other product looks better for my specific tooling that I need, right? Because they have this is where they're really solid. And our business use case really needs that extra little something that partner has. Well, OpenTelemetry lets you kind of collect those metrics, logs, traces, other data too, and be able to do a lot with it to kind of prepare and send it where you want, right? So instead of having to have those agents, right, you can instrument your applications as you should with OpenTelemetry to kind of get the telemetry that you want. And then you can send it to your collectors that you may be managing that can send it to whatever endpoint that you need to. So case in point, why OpenTelemetry is really cool. Let's say that your applications are instrumented with it and you have vendor A and you're like, hey, vendor A, you're getting really expensive. I want to see what else I can do. I'm kind of looking at this other vendor. Their pricing looks good. And I want to be able to check out what they can do with my data, right? So you could take a subset or potentially, during a migration, you can say, hey, I'm gonna use vendor A, but I'm also going to use vendor B. But you're not incurring the cost of that performance-wise on a system that you're like, hey, right, I need to have 2 agents running from these that is taking up more CPU memory, etc. Right? I can just take it and I can ship it to a couple different locations for a short term if we need to kind of see which one's going to work. We like this better. We want to move over. So when it comes time to do your migration and cut it off, you can actually kind of have almost like a blue-green deployment, right? But you have them both running for a period of time, make sure everything looks good, and then you can cut the other one off without having to worry about, adding all these agents, managing that agents. If you have thousands of nodes of whatever types of devices that you're getting your telemetry from, that's a big lift to install, make sure they're configured, make sure it's managed in the way you need, right? If that's just baked into your applications and you're sending that data, right, or your pipelines, then you just change where it points to at the end. So it's a lot of flexibility. Customers are really liking how well that project is maturing. And, pretty much every observability vendor is moving in that direction if they aren't already.
That's brilliant. And I agree with you that just thinking that through on the idea of, okay, because you're right. How many agents do we want to bolt on? Well, really none, right? Or if one, we want it to be universal and just have it cook out. I'm just repeating you now because I wanted to sound smart, but I love that. I absolutely love that. Okay.
And
go ahead.
One more thing, if I can add, there is also, this is without changing any of your code. This is just the collector config which you define as part of the ADAT as a Lambda layer, and then you can switch the exporter configuration, and without changing any code, you just switch.
Well, and as much as it kills me, Nelson, it'd probably work in Kubernetes too.
Yeah. One thing I will call out, because I think it's very important.
Throwing out, what's that?
I was going to say there's one thing that I think is really important around what Rahul mentioned is OpenTelemetry, especially when it comes to serverless, but running it in general, loading those libraries, being able to utilize it does have a performance cost that's associated with it. So one of the things that we've seen from the serverless space specifically is that if you need a really low latency application, like the general OpenTelemetry Lambda layer that we have, sometimes isn't an option just because the performance is I think it's a few hundred milliseconds. I don't remember exactly what it is,
That's right.
but it's significant if you need really low latency applications.
Okay, interesting.
Yeah, that's all. That's all I want to say on that.
No, it's good stuff. But, all right, so we spent a lot of time on traces. Now, here's my next question for you, and we can move on to the next slide if you want. That helps, though. Sometimes there's gray area between logs and metrics, and actually this might help common pain points and stuff. Talk to me, kind of separate those out. When do I use logs? When do I use metrics? And maybe we can jump in here as well.
Do you want to jump on that, Raul?
Sure. So logs basically it's a timestamp based events which are happening in your code, right? With the different parts of the code. Matrix is basically a time series kind of database where it's at this point based on what was how many requests failed. It's some kind of numeric value of the state of your application which you collect over a
Okay.
period of time. That's the metric. Whereas log is continuous execution statements. How does it help and in which scenario? Logs is basically to debug your application if you are trying to put some execution. Okay, you entered this function, you exited this function. This is good. Whereas metrics really is a collection of over in 30 minutes how many times this lambda function failed and for what reason, that kind of thing. What was the latency or what was the P99 latency over 5 minutes? These kind of things. That's the main difference. And how do you do that? They can dive deeper.
All right, prepare yourself, one of you, and I'm gonna give you a moment, but I'm gonna have you explain P99 at some point, because that is a hard concept, I think, for Eric Johnson sometimes. But he's not a very smart guy. But by the way, we got to thank you for the clarification, Joe. Good job. All right, so talk to me about common pain points here. Joe, I'll let you jump in on this.
Yeah. So P99. So P99 is it's a percentile. That's what the P is. So common dimensions we see for percentile are like P50. So like 50% of, this workload or how, when this is going, the number of requests, 50%. Let's say latency. Latency is a great P metric to look at, whether it's P50, P90, P99. So 50% of your workloads are seeing this number of latency, right? Which is usually the lower end of latency. As you go up and you go to P90, 90% of your workloads are seeing like this average latency, which is going to take into considerations like aggregating against a larger pool. And the 99% is the same type of thing, but it's most of your workload, 99%. 99% is going to be a majority of what your customers' experience is for most companies. And so as you generally look at P50, P90, P99, you tend to see, if we're looking at latency, you tend to see it increase as you go up to, what the latency is for that. So general optimization, like best practice, is like look at that P99 because that's what most of your customer experience is going to be, and try to optimize around what that is, right? And those are just some common specific metrics that P50, 90, and 99 that customers generally look at. And in most tools that have the percentile breakdown, that's what you tend to see as well.
Okay. It's interesting to me that you have a break between 90 and 99. This is only 9% more. And so I've always kind of like, well, but.
Yeah. But you can see some significant differences when you look at those metrics too.
Okay, very interesting. And we've got, and I know in CloudWatch and when you're doing that, we have where you can break it down by P90 and you can look at that. Okay. So, all right. So let's move on to the common pain points. And I don't see any questions coming in at the moment. So, but like I said, I've got plenty. So this is something I love, observability, and I love learning more about it. So, common pain points.
Sure. So request tracking, request tracing. Talk about tracing again, right? Like distributed systems are hard because they're not all in one place. They all interconnected. And as you mentioned earlier, Eric, they can be all over the place. They can be in different things. You could have an application that literally has components running in EC2, have components in ECS, EKS, potentially even on-prem, that all have to work together and have to have their own responsibilities depending on what services that they are providing, right? So,
well, and in the SaaS world, I told you before we started this, I told you I was going to interrupt you.
Yeah, good. Thank you.
So that's all right. But he hasn't got mad yet, so we're good. In the SaaS world, which is the software as a service, because we are a lot of those you don't have control over.
It's true.
A lot of us are dependent on authorization, authentication systems that we pay for to use, or storage, or there's all kinds of different ideas there. But so in that request tracking, that makes it even more complex.
It does. Totally. It does. So Prior to coming into this role, like for the past, I've been at AWS for close to 4 years. I've been working with ISV, so SaaS partners, specifically those types of solutions. So customers that use those tools, they need to have some visibility into how long those different services that they're utilizing from their SaaS provider take, right? Having metrics around that. And sometimes some vendors actually distribute additional metrics so they can understand how the internals are working, that they can share with their tenant on how things are performing. But it's really vendor to vendor. But those are things that you would want to consume and have an understanding of how that SaaS provider that's downstream you have no control over. You have control of calling that API, and you can see how long it takes to call and return.
That's right.
And depending on if it's synchronous or asynchronous, how you do that, how you manage it is different too, right? Because if it says, we're processing it, and then we have to come back later and it's done, and then say, okay, it finished. Well, then putting the connection, when do we start? When did we end? And how long is that in between? Right. And having
how do we, that's right. And how do we chain those metrics together? We talked about IDs passing around. I'm sending out, I'm doing a payment through Stripe, which Stripe has a great integration with this, right? They use EventBridge, and you can do webhooks and stuff like that. But how do I make that one continue? Because asynchronous, and it's really funny because we talk. I'm going off the rails.
No, let's go.
But when we're telling people, we tell them. Sorry, a message caught me there. We tell them asynchronous never possible, right? That's the event-driven world. Synchronous should only be used when you absolutely need it. Always go asynchronous. It's more forgiving. It costs less money in a lot of ways, depending. But it introduces this complexity of a broken line of communication, right? It's not synchronous. I'm not holding that talk. I'm saying, let me know when you're done, and hopefully I get the right response back, and I know who you're talking about. So yes, this is this tracking issue becomes, and there's been a lot of work done around. I do a whole talk on how do you pass identification codes, idempotency codes, those kinds of things. So it's complex.
Yeah, no, for sure. And I think one of the things that's nice, and I'm going to kind of come back to our tracing that we have, like X-Ray has a lot of native integrations between our services, especially messaging and asynchronous type services that we utilize that kind of help you pass that along. But when customers start to move to open telemetry, some of what they learn is that it isn't as smooth of a transition where you can just click that checkbox, right? Click it for API Gateway, click it for Lambda. It's going to collect stuff like with integrations with DynamoDB, across SQS, things like that, where when you're using OpenTelemetry, you end up having to send that payload that contains the data regarding the trace, correlation ID, other things like that, that you can then reconnect it once you pick it back up. So like service, SQS, right? You have your queue, right? And then you send it here. You send the payload that includes not just your like data, but also what's related to like that trace ID, correlation ID, et cetera, that you can link it back together. So when the other side picks it up, it can reconnect it, because it's not just passed through the headers and a part of like the context object by default. Right. And so it's a new challenge when you're leveraging that if you were using X-Ray previously. Right. And it just adds a little bit of a layer of additional code that you're going to need to continue to kind of interlink things together. And there's more complexity, but I'm trying to keep that also a little bit higher level.
Again, this, it's funny. I will say this. When we first started, this is like, well, we have enough to talk about. You always wonder when you look at stuff like that. But we go hours on this because there's so much that can be done and talked about this. So, Rahul, did you have something you wanted to add?
Yeah, just one thing to add on the correlation ID is, because we know it's so important, how do we make sure it's there, right? Always. Yeah. So that is where Power Tool adds a lot of value. So Power Tool can figure out, if you have Power Tool in your code, it can figure out what type of event Lambda is getting, if it is coming from, let's say, API Gateway versus SNS versus EventBridge. And based on that, it has a mapping defined behind the scene where it can figure out the correlation ID, whether it is getting from the header, whether it is getting from the payload, or whether it is getting from the context object. So instead of you defining or injecting your own correlation ID, of course you can override those as well. But by default, if you give using the JMS path expression, you can say where it is coming from. But if you don't give it, by default, it figures out based on the event source where it is coming from. That way you don't have to do any work there. And then it just passes on to the subsequent downstream applications.
Mm-hmm. I love Power Tools so much.
Yeah.
So much.
Yeah. If you didn't Power Tools is super cool. There's so much work there, and I posted a link earlier that'll get you into that was a Python, but we have Power Tools for TypeScript and Python and Java.net, right?
Yeah.
I may be making that one up. So yeah, but I heavily encourage you to check that out. Okay, performance optimization. What's the pain point here?
Oh, I mean,
let me throw this little grenade in the room.
No. That's there. So, I mean, performance optimization. When do you do that? Right? Like, is that before? Is it after? Is it? Oh, we're having an event and we need to look at that and see what's going on, or did we have a deployment and now we're seeing performance degradation somewhere? We just see the app is slow, and how do we kind of figure that out? Well,
right.
With distributed applications, that's hard, just as we mentioned before. They're hard, right? Where is the performance impacted, right? Or where is it not performing as well as we think it should, right? You have to understand through that trace, like going end to end, which service or like, what services are being used as a part of that microservice are seeing higher levels of latency, or just latency you think you could potentially optimize against. So as a part of the tracing, and understanding the latency of the individual spans, the different actions that are occurring, you can look at the various dependencies of what's going on between services and start to understand how much latency each one has, to where different scenarios, if you're not in an event where you are currently impacted, but you're just looking like, we know we want to improve the performance of this because we want a better customer experience. And we need to know where in our application we start to do that. Right? Understanding how long each thing takes from start to finish, where we could potentially optimize that based on how much maybe that P99 latency we were talking about before is, or even around like that side of things. If you're doing some sort of like application performance monitoring and you're monitoring those metrics specifically, you could even create something around like service level objectives for the specific dependencies. Let's say you have like get item from DynamoDB kind of thing, right. And you want to be able to specifically track how long that's taking because you have thousands of those calls going on. You can actually create an alarm based on that service level objective, so that if it hits a certain threshold, like let's say it's supposed to be like 20 milliseconds, but that the application will be impacted and there will be downstream impact if it gets up to 100 milliseconds, right? That's going to happen and cause a cascading effect, right? Well, you can actually build alarms based on looking at how much latency that's taking over the period of a time, and you can be notified whether you broke that threshold or before that threshold, or even as you're approaching it. As it's growing, you can get notified so that, if you need to fix something before it breaks, you can do that. Or on the better case scenario, if you're just looking to optimize because you believe you can improve the customer experience, the latency for all of those dependencies and all the actions that are taken, you can take a look at that holistically and choose where you think could be potentially best to optimize.
So there's a couple things I want to kind of touch on in this. We're not going to get through your deck, just so you know that.
That's it.
Because as I'm thinking about this, okay. So we have some questions. Okay. So thanks, Jeff. Jeff and I were talking in the background here. We have some questions from Victor. I'm not sure I understand the question. So I'm going to try this. The question is, all right, so he's talking, hello, the rest are from the source. I'm sorry, I'm trying to figure this out. The question is, how can they suggest those user accounts on Facebook? Also the answer, so Victor, I don't understand the question. I'm sorry. So if you can kind of ask it again or ask a simpler one, and then we can kind of build into it. I'm really sorry, but I don't even know where to go on this. now that I've done all that on the live stream, so everybody can hear that. So I told you this is a casual show. So here's my question: performance optimization. This is one of those things you do in production, but you also can do before you ever hit production, especially with serverless. One of the coolest things about serverless is you can have the exact matching architecture in a development account, right? Yep. Generally, at not a lot of cost until you run it up and down, things like that. If you're doing like RDS or something like that, that adds some complexity, but it can be done. But you can usually, especially if you use an infrastructure as code, like a CDK or a SAM or an SST or something like that. But then you can run load on a development account and check these metrics, right? And one of the questions I always think is fun is, we'll get back to the question here, is so how do you set up metrics? Well, you can go into CloudWatch, but really, and let me ask you this first, Joe. How do you set up a metric usually? What's the process?
So there are.
Rahul.
Yeah, no. Do you want to take it, Rahul? I feel like I talked a lot more recently, but if you want to, please.
Okay, I mean, please go ahead. But one thing I'd definitely like to talk about when it comes to custom metrics and the performance optimizations. Initially, this is the real problem I dealt with the customer actually. They used to call for all the individual components of the code. They used to create a custom metrics and call the API, put metric data API. There are two downsides to that, doing that way. One is, of course, the cost. It is costlier to create it that way. But the second one is it is synchronous call. So your code is blocked at the moment when you are creating that metrics. So AWS came up with something called EMF, embedded metric format, where basically you call the put log events. I think it's called the API name. What it does is it actually logs asynchronously, but it also instructs the CloudWatch service to create a metric out of it. So in just one call, you are creating log as well as the custom metric. That is very important, not just to save on cost, but also it is asynchronous. So it is your code is running faster and your customer experience is super fast, basically. So that performance optimizations comes from a real world scenario, which I wanted to put it out there.
Nice. I didn't know about that. I'll be really honest. So that's really interesting. So create the log and the metric at the same time. One of my approaches, I do everything. You'd be really hard pressed to catch me in the console sometimes, because I am very rarely in the console. I'm almost always in infrastructure as code. But one of the cool things is creating metrics and alarms and things like that right in infrastructure as code with Kiro CLI or Kiro, and just tell it, hey, I want to know what this looks like. Throw a metric in, and I'll usually do that as a substack. So I'll have a substack of metrics and things that I want to track. I can even have it build a console. One of the cool things is you can build a console in CloudWatch and export the JSON and just drop it in there so you can recreate that anywhere else. That's a little chicken and eggy, but you get it here. So I do want to come back to Victor's question. I think I've kind of got it. I'm gonna throw it up here. It says how can the end user have denial of service for compliance? I'm thinking is the word, because the AWS or other channels. How do we? So maybe I'll translate that a little, or if you all have ideas on that. So he's working on a proof of concept for logging. How do you log denial of service? Or how do you watch for that?
Yeah, I think when it comes to, if that's the question, when it comes to that, generally you would see, like, if you're looking at your, hold on, just seeing what it says. If you're looking at the number of requests that are coming in and you see like an exponential spike that's starting to come in, right? And you notice, you could see other metrics that are correlated to that. If let's say you're looking at your CPU utilization and you have a CPU heavier app, all these requests come in, you can start seeing errors as like maybe your APIs aren't able to take the amount of load. There's many different areas of metrics that you can start to like correlate that and try to see. You're going to see a number of requests increase with the denial of service because that's what's happening. You're going to see that significantly increasing. And then that starts to have the downstream implications depending on how you built your applications and, how it goes through, right? And what load that your applications can take. Part of that, like, it can be difficult to then kind of understand what's going on without having to bounce around between the different tools. Say you see this denial of service is coming, you see that, or like you're experiencing that, you see the request coming in, you then need to go take a look at the logs, see where the requests are coming from, do some analytics, identify where most of those are coming from, and then, block where they are potentially are coming from. But you are going to end up using like metrics and logs to dive into that deeper. I think that's kind of understanding where everything starts, what applications, what metrics are available to you, and then how everything else kind of connects. It's going to be more than one. But the initial request count, if you're looking at that for your application, you're probably going to be seeing that significantly increase. And you'll see the graph that goes like, maybe it's up and down a little bit, but then it's going to be like really going up high.
Yeah.
And don't discount the other services like AWS Shield, for example, that is specifically designed to stop these kind of DDoS attack or detect at least. So you don't have to you don't have to do it in your own application. So there are some cross-cutting edge kind of services which should be used ideally for those kind of things.
So we had Skigama said VPC flow logs and then use NACLs. WAF is another one.
That's definitely another way to do it.
A lot of that's built in. Okay, so Nelson read the question is how can a customer auto DOS themselves with logs? Okay.
Oh yeah.
Just a guess. Yeah. All right. If that is the case, I thank you, Nelson. I appreciate that. I think IO for production workloads where you log too much can be how.
Yeah, I mean that can definitely happen too. Like if you're sending too many logs and whatever, like let's say you're putting the put logs stream and you're just sending too many logs, or if you're capturing them in another way and you just kind of overwhelm what the downstream system is that you're sending all those logs to, right? You could potentially cause yourself a denial of service from there, but then you kind of have to assess, where do we scale? Like, is that something that we scale the back end because we absolutely need those logs? Are you able to take and like dedupe some of those logs so you're only getting what you actually need and sending what you need? Maybe you do need all of those logs. At that point, you would have to potentially look at scaling downstream or how you could batch those if possible to where you're batching those and flushing those logs at a specific rate, right? Yeah. There's potential for that as well.
Okay. So I'm going to change course for just a second because we are kind of running out of time. I want to go back to performance optimization for a second, and I want to bring up this statement here from Nelson. Some great feedback from Nelson. This is I find it quite meaningful for peak events, most often than regular performance issues, to know if your workload can handle peak events. How do you do that? How do you check for peak events?
Well, you'd have to be doing some load testing beforehand. And understanding the latency of those calls, understanding what your systems can handle. If you don't test it, there's not really a good way that you're going to know. You can make some assumptions, but if you can actually make an estimated guess of what you believe that traffic's going to be and try to replicate that, maybe not in production. It'd be like, unless you are confident that you could do that in production, potentially. I mean, it depends on if there needs to be that immediate response. Like if you have an asynchronous system, maybe it can handle it a bit better than if you have more synchronous APIs that you have to work with. But you just kind of have to validate it and look at the same thing, those latency metrics that you have around those specific dependencies to understand, as you get those increased requests, those peak event requests, can you handle that load? And if you can't, at which level downstream with the distributed systems is going to become impacted, right?
Yeah. Right. And Lambda, specifically for Lambda, you can also measure the out-of-the-box metric for concurrent executions and just compare it against the threshold of what your account or quota limit is. Once it reaches that concurrency execution metric reaches 70%, 80%, then you can basically address that way.
Yeah. We used to, I don't know if y'all, so for load testing, and these are just things we used to use, not necessarily recommendations, but they used to be, it's still out there. I just looked at serverless artillery, which actually will just bombard your system. You need to call an API, you need to call something like that. But I do encourage you to load test. It's an important thing It's super helpful. Test your equipment in serverless makes it easier to do that. Okay, so go ahead.
Can I steer this with the last few minutes, because I think this is important, and we're coming back to AI. Because everything has to talk about it. No. But in reality, the reason I'm bringing that up, we talked a lot about like the different observability data types, right? These signals, but like most organizations I'm talking with a lot are really interested in AI operations. There's a lot of interest around, how do we reduce our mean time to resolution, right? MTTR. The one thing that a lot of agents are getting really good at, if they understand, like have access to your telemetry, they understand like with the traces, what end-to-end good looks like, they're able to start to use this telemetry if you have it all in there and you have what is impactful for your business, and understand what the boundaries of those are, to be able to consume that telemetry and decrease MTTR, right? Like from the standpoint of something we released at reInvent, it's still in preview, the AWS DevOps agent, right? That frontier agent, which it's in preview now. You can check it out. I won't go dive too deep in this specific venue, but all of the partners have these different agents, from Honeycomb to Datadog to New Relic, have these different ones. And even like Dynatrace specifically integrates with our AWS DevOps agent, to where they call the webhook and they can do investigations based on things they see, leveraging the DevOps agent within the accounts in AWS. But the industry as a whole is moving towards like, what is happening in an observability from an incident response standpoint is really evolving, just like all the AI stuff is. And companies are seeing the value of having AI for AI ops as a part of their day two operations. Like a lot of that is really moving that way. And even if it doesn't get there immediately, give you the right answer, but when those things trigger with an alarm that could be impactful, they can start looking at it before a human, and they do a really good job starting to collect that data, especially if you have the good data there for them and they understand how those things are connected, to start to be able to identify what potential causes are. And even more so where they're attached to, your specific code repos that are related to those, and they understand what's related to each, right? Where they could say, hey, we see something has changed. These metrics all align across these things. Was there a deployment? There was a deployment. What's changed? Right? Oh, this changed with a part of this deployment, and then we're seeing degradation since that was deployed with that change. All before a human can be involved. A human can come in and review, and potentially those agents can give you an idea of what you need to fix, or in some instances with some vendors as well, they might even make a PR.
What a time to be alive. I mean, literally, we keep telling ourselves that, but it's like, whoa.
It's a wild time.
Yeah, we could go down a massive rabbit hole with this, but I'm going to pause us there. Some fantastic questions, great content. Joe and Rahul, really appreciate you taking the time to join us. We could do 5 more sessions on this, to be honest. Observability is so important, but it's such an afterthought for so many people. So the takeaway on this, and my call to action for you is, start looking at your observability story. Is it telling a story? Is it telling the full story? Are you using the tools available? Check out Power Tools, check out X-Ray, check out the different things that we mentioned. With that, first of all, I want to shout out to Jeff, who is always keeping us just cruising really good. Jeff, thank you so much for all your hard work. And gentlemen, I'm going to have to wrap it because we are at time. So thank you very much for joining us. And we'll see you all next week. Same time, same place. Julian will be back. And we'll see you later.